In this video, we are going to learn about wacker process. So here, basically oxidation of alkene is happening. Oxidation of alkene, that is the main reaction using palladium catalyst. Palladium catalyst is used. Okay. So the catalyst looks like this. Palladium and then Cl4 and then 2 minus. So this is the catalyst, and then there is a co-catalyst along with this. So this co-catalyst is CuCl2. So cuprous chloride is the co-catalyst. Okay. So here mainly a few different reactions are happening. Let's see that like in a simple way, and then we will move on to the mechanism. Okay. So firstly consider an alkene, CH2. I am considering a simple alkene, okay, ethene, okay. Now here what will be present? The catalyst, or palladium catalyst will be present, and then this co-catalyst will be present. Co-catalyst, what is meant by? They are promoters. They will help the catalyst for improving the rate of the reaction. Then co-catalyst is present, and then oxygen will be present. And now we are considering water as the solvent. So what will be the product here means CH3, CHO. So acetaldehyde will be the product. Consider we are taking this like higher alkene. Okay, I am taking a higher alkene group. So a big group or group is present here. The same thing. Okay, same set of conditions. I am taking water. Now what will be the product is ketone will be the product. Okay. So ketone is the product. Okay, see, as you can see here Markov-Nikov product is formed. What product? Markov-Nikov. So already we know, according to this rule, hydrogen will add to more hydrogen carbon atom, right? Add more hydrogen carbon atom. So that's like a simple trick to understand. Like remember this product, like here this carbon is having the more hydrogen, right? Similarly, this carbon, consider this carbon is carbon number 1. In that carbon only we have added hydrogen. That's why like it's like a Markov-Nikov product. Okay. Then consider the same simple ethene, CH2. Instead of water, if you are using acetic acid, CH3COH, all others are same. Like the CuCl2 is same, the oxygen is also present, the palladium catalyst is also present, but instead of water we are taking acetic acid. Then what will be the product is vinyl acetate. Okay, OCOCH3. Later on we will see in detail about these mechanisms clearly, so that you will there is no confusion. Okay. Similarly, consider you are reacting with alcohol instead of acetic acid. You are reacting with alcohol. So this is vinyl acetate. Vinyl acetate is formed. Then here what will be formed is vinyl ether is formed. Okay. Vinyl ether is formed. So these are few reactions you have to understand. These are the reactions happening with this palladium catalyst. Okay. So this palladium catalyst properties. What is the properties means? So basically the structure of this catalyst is square planar. Square planar structure. Okay. Square planar means what is the hybridization? DsP2 is the hybridization. Okay. So basically 4 ligands. Whenever this palladium is having 4 ligands, the palladium will be in +2 oxidation state only. Okay, let's find what is the oxidation state for our compound. Palladium Cl4 and then 2 minus is present, right? So let's take palladium as X and then Cl4. So -4 is equal to -2. So X will be what? +2. So palladium is in +2 oxidation state. So palladium, what is the electronic configuration? 4d10. Outside electronic configuration is 4d10. Then for palladium 2+, it will be 4d8. Now we have to know whether it is diamagnetic or paramagnetic. Okay. So since it is a square planar complex, it will look like this. Okay. So their orbitals will be filled like this. So here dxz You might have learnt about these octahedral, tetrahedral and square planar in coordination chemistry, right? For square planar, this is how these orbitals are arranged, okay? And then here it will be like d, so upside it will be dx square minus y square and then dxy, here dz square. Basically z's are present downside and then x and y will be present outside. Now I have to fill 8 electrons, okay? 1, 2, 3, 4, 5, 6, 7, 8. As you can see, all are completely filled, all are completely paired basically. So it is diamagnetic in nature. And then here the dx square minus y square orbital will be responsible for bonding with a chlorine. And then see in this dsp2, the p will be what? Px and py. D will be dx square minus y square. So let's move on to the mechanism part. So this mechanism is very, very important. So very easy mechanism only. See, initially our catalyst is present, palladium, Cl4 and then 2 minus. So our catalyst is present, okay. Now let's write this in a structure form so that it is easy. Palladium, so it is square planar. So Cl, Cl, Cl and then Cl, okay. And then here 2 minus is present, okay. Now what is happening is we have to introduce an alkene into this structure so that it can be oxidized, right. So I am going to introduce an alkene. So simple alkene I am taking 18. So if you have to introduce something, there should be space. So this palladium can accommodate only 4 ligands. Then only it will be in +2 oxidation state. So something has to be removed. So chlorine. So one chlorine is removed, okay. And this is going and attacking this place, okay. Any place. You can consider any place. Okay, so palladium, chlorine, chlorine. Here also chlorine. And then here what is present? RCH2 is present. So now for each step you have to put the charge in this place. Okay, so how to find the charge? For palladium we know it is in +2 oxidation state. And then for each chlorine I can put -1, -1 and -1. Right. So -3. And this is a pi complex. Okay. So pi complex will not contribute. It will be 0 only charge. Okay. So we will not take anything. So it is equal to 0. So how many it will come? -1, right? So here -1 will be present. So for each step in mechanism, you have to put this charge in the upper right corner by finding. Okay. Then what is happening here? We are adding H2O. Already we told, right, we can add H2O or alcohol or acetic acid. In this simple mechanism, we are going to see H2O. H2O means H plus and OH minus is present. This H plus will be removed, okay. So what will be happening is this OH minus will come and attack this carbon, okay. Then there will be 2 electrons in this bond, right. So that 2 electrons along with that bond will go to our palladium. As you can see, there is a sigma bond forming, okay, between the metal and the carbon, okay. So initially the metal and carbon had only pi bond, pi complex formation. So now this is the sigma bond, okay, as you can see. So this is the sigma bond I am talking about. So sigma bond is formed between palladium and a carbon. So consider this is as carbon 1 and this is as carbon 2. So OH is attacking in carbon 1 and carbon 2 is attacking where? This palladium. And then only one bond is there and then CH2 and then OH. So here also CH2 is present, okay. So now I have to do the calculation for charge, right. So for charge for palladium it is +2 and then each chlorine will have -1 and also this compound will also contribute -1. So initially here in this case the pi complex, that CH2 didn't contribute anything, but here it is -1, okay. So totally -4, so equal to what? So -2 will be the charge that will be present here, okay. So now we have completed this step, okay. Now consider the beta hydrogen. So this is alpha and this is beta. So because this is the metal, from metal only we have to notice alpha and beta. So here a hydrogen is present, right? So take it as H1 and hydrogen, just take it like this, okay. So now this hydrogen is now going along with this 2 electron. This hydrogen is going to attack this space. Okay. So basically hydrogen transfer is happening, and then what is happening is this 2 electrons from here, it is going and attacking here and forming a pi bond. And then this chlorine will leave because hydrogen is going to attack the palladium. There should be space for hydrogen there. So chlorine will leave. Okay. So minus Cl minus. So hydrogen transfer is happening. Okay. Hydrogen transfer. Why this is happening means then only we can attach the hydrogen to our particular compound. Okay. So palladium, hydrogen and chlorine. One chlorine is removed. So only 2 chlorine is present now. And then now what is happening? Again it is like a pi bond. See, because this sigma bond, sigma here initially it was sigma. Now it is pi. Okay. So CH2 and then CH and then OH. So this is our new product now. Okay. So now what we have to do? We have to attach this hydrogen to our compound. So this hydrogen has to be attached to our compound. So hydrogen along with this 2 electron in this bond will go and attack this carbon. Why not this? Consider this is 1, this is 2. So why not attack the second carbon? Means here only you have to note that Markov-Nikov. Okay. So basically the hydrogen will tend to attack the more hydrogenated carbon. Okay. So then what will happen here? 2 electrons will be present, right? These 2 electrons will again go and attack the palladium. So now sigma bond will be formed. So in this step I have not done the charge. So how to calculate charge? X. 2 plus 2 we will consider for palladium, and then for hydrogen 1 minus 1, 2 chlorine, so minus 2. That's it, right? So what will be the answer? It will be minus 1. So here the charge is, in this step it is minus 1. So in the next step what is happening is, since hydrogen has gone from here, we need a chlorine now. To attain 4 ligands, we need 1 chlorine now. So we are adding 1 chlorine to fill that space basically. So in this space hydrogen was there. Now I am filling that with what? Chlorine. And then now sigma bond is here. Here sigma bond is here. And then in C, the first carbon is attached to what? Hydrogen. And the second carbon is attached to what? Palladium. So we have to note that. So this is the second carbon that is attached to the palladium, and the first carbon is here. Okay, so this is first carbon, this is second carbon. Okay, have you understood? So in the next step what is happening is, consider this OH is like this. Okay, for understanding I am writing it like this. So what will happen is, this chlorine along with this 2 electron, so this chlorine is going and attacking this hydrogen. Okay, so H plus. So this H plus and Cl minus will join to form 1 HCl. And then here there is a bond with 2 electrons, right? That bond will go and join here. Okay. And then there is 2 electrons in this bond, right? 2 electrons that is gained by palladium. So here what is the oxidation state of palladium? Here the palladium oxidation state is plus 2. In this case plus 2. Then what about the charge? For charge plus 2 we will take for each chlorine. So how many chlorine is present? 3 chlorine, so minus 3. And then another one sigma bonded carbon, so minus 1. So totally how many charge in this step? Minus 2 charge. Okay. So now what is happening? 1 HCl is formed. Then what is happening? This palladium is gaining 2 electron. It is gaining 2 electron. So from plus 2, this palladium has gained 2 electrons. So it is converting into palladium 0. Okay. Then this chlorine minus and this chlorine minus will be released. So 2 chlorine minus. And then finally CH3, CH, here double bonded O will be there, right? See, this step is very important. So this 2 electron is coming and attacking this space. So what will be remaining? CH3, CH2, CO, right? Plus CH3, COH. So acetaldehyde will be remaining, okay? So this is carbon number 2. So carbon number 2, not hydrogen 2. Okay, so this is carbon number 1 I have mentioned. So basically this will be the products. Okay. From this step what will be happening is, So this palladium is actually a catalyst. So we might have learned that catalyst always it is regenerated. So we have to regenerate this catalyst. So what is happening is this palladium and then this 2 chlorine, 2 Cl minus, and then now only our co-catalyst is used, CuCl2. So initially this co-catalyst is in +2 oxidation state. So now the product will be, again the palladium catalyst will be formed, okay. So basically from 0 it is converting into +2. So it is what oxidation is happening here. So someone is oxidizing it. So copper chloride is the oxidizing agent and it will be reduced to CuCl. It is reduced to Cu. So reduction is happening. For copper chloride, reduction is happening. So here the copper oxidation state is what? +1. Okay. So now you just have to balance the equation. Here 2 will be coming and then here also 1, 2. So this is the next step. Next what we are going to do is, again this copper chloride, I need it back into copper chloride, Cl2. I want to, from CuCl, I need back the CuCl2. Okay. So what I have to do here, it is in +1, here it is in +2. So what I have to do, oxidize. I have to oxidize. For that we are using oxygen and then we are also using what, HCl. So CuCl2 plus water will be the product. So then we have to balance. So this is the final. So basically this copper chloride, that is this cupric chloride, is used to oxidize palladium 0 to palladium 2 plus. And then this cupric chloride is further oxidized into, this cuprous. So Cu in +1 oxidation state is cuprous, right? So this cuprous is further oxidized into cupric chloride by using oxidizing agent as oxygen. I hope you understood the whole steps. Okay, next let's move on to higher alkene. Okay, so or is present and then carbon, hydrogen, CH2. So now I am going to make this into ketone. So why I told earlier, from normal alkene we got acetaldehyde. Now here we will get ketone. So how we are getting ketone instead of aldehyde, that's what we are going to see. Okay. So initially what will be this titanium, our metal will be present here, right? The palladium metal will be present here along with our whatever chlorine. I am not going into detail about this chlorine releasing. Just imagine this metal is connected to this. Okay. Now what we will add, H2O. So H plus and OH minus. So this OH minus will go and attack where? So H plus will attack the more hydrogen atom. So OH minus is going to attack, this is 1, this is 2. So basically this OH minus will attack the carbon 2 only, not 1. Okay. So this carbon 1 will attack this palladium. So here see, if you see here 2 electrons will be there. Along with the 2 electron, it will go and attack our palladium only. Okay. So our palladium is there and then CH2. So this is carbon number 1 is attacked to the palladium, and then carbon number 2 already hydrogen and OR is present. Extra we have 1 OH in this carbon number 2. So this is carbon number 2. Okay. So rest of them will be, we already know, right? So now what will happen? This hydrogen, right? So this is alpha, this is this is alpha carbon and this is beta carbon. We know beta hydrogen will transfer to the metal, right? So beta hydrogen is transferring from here to the metal. Okay. So next what will happen? This bond will go and attack here, right? So what is happening? Palladium is there and then 1 hydrogen is bonded to our palladium, and then there is double bond now, CH2 COH R. So this is what it will look like. Rest will be chlorine, everything. Okay. So next what will happen? This hydrogen will attack the more hydrogenated carbon. So of course this will attack this carbon and remaining where this electron along with this will go and attack here. Okay, so what will happen? Palladium, and then here CH. See here, you have to write this step very carefully. So this is carbon 1 and this is carbon number 2. Okay, so now our hydrogen is attacking carbon 1 and the see these electrons along with this second carbon will attack where? The palladium. So basically the palladium is attached to which carbon? Carbon number 2 only. Okay, OH is there in carbon number 2 and OR is there in carbon number 2. And this carbon number 2 is attached to this carbon number 1. So this is how it will look after this. Okay, now rest will be what? You already know, it will be chlorine. Okay, now what we have to do is, so this is the hydrogen that we are going to release along with our chlorine. Okay, so what will happen is this hydrogen is going to, so here one chlorine will be present, it is going to attack the chlorine and what will be released? HCl will be released, and then here this bond will go and attack here, and then this electron will go and attack palladium. So remaining what is the product? As you can see, C, carbon, I have written carbon, and then here the bond, double bond O, and then OR is present, and then CH3 is present. So ketone is formed. As you can see, clearly see ketone is formed, and then 2Cl minus will also be formed. So these will be the product. So let's move on to acetic acid. What about acetic acid? At what step it will reach the product means CH3, COOH. So here the H plus will be removed, right? So consider this is palladium. So here the H plus is removed, and the CH3 COO minus will go and attack this carbon, and this 2 electron will come and attack this palladium. Okay, so what is happening? Palladium is there, and then our carbon CH2 will be there, and then CH2 O CO CH3. So this is how it will be. Rest will be what? Chlorine. So now this is alpha carbon, this is beta carbon. We already know that the beta hydrogen. So the beta hydrogen will go and attack where? So it will go and attack here, and this will be forming here, and then this will go here. Okay, so now what will happen? Palladium, and then hydrogen, chlorine, and then CH2, CH, O, CO, CH3. So here in this step itself it will be ending. The hydrogen will not come and transfer to this particular carbon. Those steps will not be happening in this case of acetic acid and in the case of alcohol. Just this compound will be dissociated and you will get your product as vinyl acetate. So this is the last step for this particular acetic acid reaction. Okay, like the earlier things, it will not be happening. Okay, consider for OH. So this is our palladium and it is attached to our CH2. Consider for OH, if alcohol is present, so this OR will come and attack this carbon, and these 2 electrons will go and attack the palladium. So it will be palladium, single bond. See, this is carbon 1, this carbon 2. So carbon 1 is attached to palladium, and then carbon 2 is attached to OR. Okay, so rest will be there. Then what we will do next step? So here one beta hydrogen. So this is alpha, this is beta. So this beta hydrogen will go and attack this palladium and chlorine will be removed. Okay, and then what will happen? This electron will go here and this will go here. Okay, so palladium, hydrogen. So this will look like this, CH2, CHOR. So now also this hydrogen will not come and transfer here. That is not going to happen. Just this compound was released. Okay, so vinyl CHOH. So vinyl OH, no, OR. This is OR, right? See, OR. Okay. So this is vinyl ether. So I hope you understood the whole mechanism and it is clear. Thank you. Thank you for watching my video. Like, share and subscribe if you like this video.